Alright, you have now learned the first derivative and second derivative test, and now we're going to be applying those a little bit. At the end of this lesson, you'll be able to use information about f prime, and f double prime to analyze graphs. Right, as we're looking at this next question, this is actually a very popular AP problem that will appear on the free response portion of the AP exam. It's a 9-point question, and usually it's pretty easy to get our points as long as we can get things set up correctly. So that's what I'm going to be showing you today. Okay, it says the graph of the derivative of f on the interval from -4 to 4 is shown. Answer the following questions about f, justifying each answer. So we have lots of questions, and if you look at those, first of all, this is a graph of the derivative of f, so this is f prime. And if you'll notice, if you look at all the choices or the parts, where is f increasing? Where is f concave up? Where does f have local extrema? Where are their points of inflection? Those all have to do with f prime and f double prime. So before I even start this problem, the one thing that I do like to do is make myself an f prime chart and an f double prime chart. So that's exactly what I am going to do. So if I make myself an f prime chart, remember,
Cameron, come to the front office for driver's training.
so we're looking at our f prime chart, and to do that, this is a picture of f prime. Remember, to get numbers, critical numbers for f prime, we're looking for where f prime equals 0. So if we look at the f prime graph, it's going to equal 0 at -2, at 1, and at 4. So those are the three numbers that get to go in my f prime chart. Okay, and then from there, if I'm looking at before -2, all of the values before I get to x equals -2, they're all positive because they're above the x-axis. So our f prime will be positive. Between -2 and 1, those values, those y values, are still positive. And then between 1 and 4, our f prime values are negative. So, and I'm just going to put, when I was looking at that, I was really looking at above and below the axis when I was doing that. Okay, and now to get my f double prime chart, what I'm going to be looking at, if this is f prime, f double prime is the derivative or the slope of that. So on this one, I'm going to be looking at the slopes. So if I look at the slopes, I notice that my slopes are negative until I get to -2. Okay, and then my slopes are positive until I get to 0. And then my slopes are negative until I get to 3. And then my slopes once again are positive till I get to 4. Okay, so now I have an f prime and an f double prime chart. I really don't care about the picture anymore, and actually I think it's more confusing to look at the picture after that. Once we have this, we have all the information that we need to actually answer the question. So here we go. All right, part A. On what intervals is f increasing? Well, I know increasing has to do with the first derivative test, so I'm just going to repeat my f prime chart here. -2, 1, and 4, and we had plus, plus, minus. It didn't go past 4. Okay, so if we want to know where f is increasing, we know that's going to be where f prime is positive, which would be in these two intervals. Please remember that this graph didn't start at -infinity, it just started at -4 and went to 4, so we need to keep that in mind when we're saying where it's increasing. So increasing, where it starts, which would be at -4, till I get to -2, and then once again from -2 until I get to 1. And remember, even though these are both positive, we do have to stop it at -2, because at -2 the derivative is equal to 0. Okay, so this is where it's increasing. It did ask us to justify our answer, which means we need a nice because statement, and this would be because. Just say your chart. F prime, what did we notice on f prime? That it was positive. All right, part B, on what intervals is the graph of f concave up? Well, we know concavity has to do with the second derivative test. So let me just redraw my f double prime chart here. We were minus, plus, minus, plus. Okay, and again, when we're looking for this, if I'm concave up, I'm looking for my second derivative to be positive, which would be in both of those spots. Remember, my this picture was defined from -4 to 4, so if I'm looking for positive, it would be on the interval -2 to 0, and then once again from 3 till my interval ends, which is at 4. And then I do need a justification, so a because statement, because my f double prime chart showed me that my f double prime was positive. So all we have to say is because f double prime is positive. All right, part C, it says at what x coordinates does f have local extrema? So to find this out, local extrema has to do with minimums and maximums, relative or local minimums and maximums. So once again, we're going to go back to the f prime chart. So if I go back to the f prime chart, I'll have -2, 1, and 4. And then I'll have plus, plus, minus. Once again, that was it there. And if I want local extrema, we're looking for relative minimums and maximums. So I'll start with the relative or local maximum, and that will be occurring at x equals 1, and if you'll notice, the reason that it's occurring at x equals 1 is because that's where the derivative is changing from positive to negative, which means the function's going up and then it's going back down. So we'll have a justification because f prime changes from positive to negative. Okay, and then for a relative minimum, is there a spot where f prime changes from negative to positive? No, there is not. So there are no relative minimum, and we need a justification, and that would be because f prime does not change from negative to positive. And then that's all we'd have to say. All right, part D. What are the x-coordinates of all inflection points on the graph of f? So again, we're talking about inflection points. It's going to be the second derivative. So let me just once again recreate my f double prime chart. Negative, positive. Okay, if I'm looking for points of inflection, we're just looking for where f double prime changes sign. I notice that it changes sign at -2 and at 0 and at 3. So all of those are points of inflection. So there are points of inflection at x equals -2, x equals 0, and x equals 3, and we do need to justify our answer. That is going to be because we really don't care whether f prime, double prime goes from negative to positive or positive to negative, just that it changes sign. So we're going to put because f double prime changes sign. And hopefully you're noticing that these problems actually are a little bit easier to do without even looking at the picture. So once we have our f prime and f double prime charts, specifically just focus on those instead of trying to look back at the picture where things can get a little bit confusing. Right, and then part E, sketch a possible graph of f on the interval -4 to 4. So again, I'm going to use my f prime chart here, -2, 1, 4, plus, plus, minus, and then f double prime, -2, 0, 3, negative, positive. Okay, remember f prime tells us where the function is increasing and decreasing, and f double prime tells me my concavity. So what I can see for this is we are increasing until we get to -2, and then we're going to increase a little bit more, and then after 1 we are going to decrease, and then we stop at 4. Okay, on this one I'm going to be concave down until I get to -2, then I'm going to be concave up until I get to 0, then we're going to be concave down once again, and then we're going back to concave up. So we are doing lots of wiggling around when we do this, okay? So I'm going to go ahead and try to recreate f here. Right, and I'm just going to start, since this interval starts at -4, I really don't know where I'm starting, so I'm just going to make up a point. I'm just going to make up the point -4, -2. Does not really matter. You could put it wherever you want. Okay, I know that I need to increase until I get up to -2. So if I need to increase till I get to -2, I'm just going to be putting a point. I know that I need to go up, and then I'm going to go up again until I get to 1. So I need my next point to go up even farther. And then after 1, all the way till I get to 4, I need to decrease. So I'm just going to have something that looks like that. So I can tell I'm going to go up some more, decrease. Now I just need to put in my concavity. Okay, so until I get to -2, I need to be concave down like a frown. Try to do this. Okay, so notice I'm concave down. Okay, then from -2 until I get to 0, I'm going to be concave up. Trying to make it go right there. Okay, and then from 0 to 3, did I put something there? Nope, 0 to 3, I need to be concave down, so I'm going to need to put another point there. I need to be concave down. Whoop, concave down. Nope, something like that, I guess. Okay, and then I'm going to be concave up again until I get to 3. Well, try as much as I can to make it look like a cup. There you go. So my f graph would look something like that. And again, yours could be up or down, could be spread out a little bit more, but that's basically the shape that it should have. So hopefully now you can analyze graphs using f, f prime, and f double prime.